Okay, so this is an electrostatics question. It's question 12 from the Edexcel paper 3 of 2015. So I'll start off by reading the question. A simple model of a hydrogen atom consists of an electron moving in a circular path around a proton. And I've sketched this here. In this simple model, it is the electrostatic force rather than the gravitational force that is responsible for keeping the electron in a circular path. By means of calculations, justify this statement. And we're given the radius of a hydrogen here, which is 5.3 times 10 to the minus 11 meters. So, because the electron is moving in a circular motion, it undergoes a centripetal force, which points towards a proton. And so there are two contributions to this force. There's an electrostatic contribution and a gravitational one. And we're asked to show that the gravitational contribution is negligible compared to the electrostatic one. So how do we do this? Well, we start off by computing both the forces. The electrostatic force, the magnitude of Fe, is just obtained by using Coulomb's law, which is q squared over 4 pi epsilon naught r squared. The constants are listed here. So plugging this into your calculator, you obtain 8.1 times 10 to the minus 8 newtons. Now let's calculate the gravitational force which attracts the electron to the proton. So for this, we can just use Newton's gravitational law. G times the mass of the electron times the mass of the proton divided by r squared. And again, using the values listed here, we obtain this time a force of 3.6 times 10 to the minus 47 newtons. So at a glance, we can already see that the electrostatic force is a lot larger than the gravitational one. And to really show this, we're going to take a ratio of both forces. So we're going to divide the electrostatic force by the gravitational one. And so dividing 8.1 times 10 to the minus 8 newtons by 3.6 times 10 to the minus 47 newtons, we obtain a ratio of 2 times 10 to the 39. So this shows that the electrostatic force is 2 times 10 to the 39 times larger or stronger than the gravitational force, which means in turn that the gravitational force's contribution to the centripetal force can be neglected, and hence it is only the electrostatic force which causes the electron to move in a circular motion around the proton. So question B. Ignoring the gravitational force, calculate the velocity of the electron in this simple model of a hydrogen atom. So, we know that the electron, since it moves in a circular motion, undergoes a centripetal force. So we have Fc, which is given by the mass of the electron times its velocity squared divided by r, which is the radius of the hydrogen atom. So this would be the magnitude. And in the previous question, we computed the electrostatic force, which has a magnitude of q squared over 4 pi epsilon naught r squared. And because we're asked to neglect the gravitational force, we can set both forces to be equal. So we can say that Fc is equal to Fe, because the centripetal force arises only from the electrostatic attraction in this model. So equating both equations here, we have the mass of the electron times its velocity squared over r is equal to the charge squared divided by 4 pi epsilon naught r squared. Rearranging for v, we get v squared is equal to q squared over 4 pi epsilon naught times the mass of the electron times r. We can just take the square root now and obtain this expression for the velocity of the electron. Plugging in the constants, we obtain a value of 2.2 times 10 to the 6 meters per second. That's part B. So the third question. In another model, it is assumed that the electron behaves like a wave, with the de Broglie wavelength lambda. The wave associated with the electron forms a standing wave whose wavelength is equal to the circumference of a circular path. Calculate the velocity of the electron based on this model. Okay, so now we're asked to consider a different model of a hydrogen atom. And in this model, the electron has a wavelength, a de Broglie wavelength lambda, and we are told that the wavelength of the electron is equal to the circumference of the circular path here. So this is just going to be 2 pi r, which is 3.33 times 10 to the minus 10 meters. And so to find the velocity of the electron in this model, we can use de Broglie's formula for the momentum, which is that the momentum of the electron, if it has a de Broglie wavelength lambda, is simply Planck's constant h divided by lambda. Now we know that the momentum is simply the mass of the electron times its velocity. We can rearrange for the velocity. And so using the value of the wavelength that we've just calculated, so as the mass of the electron and Planck's constant given there, we obtain a velocity of 2.2 times 10 to the 6 meters per second. And that's the question.